All right, now we're on to lesson 1.3, which is all about literal equations. Now remember, a literal equation is a formula or equation that involves several variables. So more than one variable is involved. There's an x and a y, there's a and a b, there's r's and q's, and there's more than one variable involved, and we're normally just solving for one of those. So we're manipulating both sides of the equation to get one variable alone. So to do this, we're just going to go through several examples here to get the feel for how to get one variable all by itself. So solve the following literal equations for the indicated variables. In example 1, we have the formula A equals BH. Now if you remember from shapes and areas, this is just the area formula for any quadrilateral. Area equals base times height. A equals BH. In this case, we're solving for h. So if I were to tell you the area of a rectangle or any quadrilateral, and I told you the base of that shape, you should be able to figure out the height. And this is how we do it. Okay, we have to manipulate this formula to figure out how to find height from area and base. Notice on this side of the equation, what is happening to h? This is what we're thinking about every time that we solve one of these equations, is what's happening to h. When b and h are written right next to each other, it's saying h times b, or b times h. So it looks something like this, either b times h, but remember this means the same as h times b. These mean the exact same thing because of order of operations and our properties of algebra. So technically, if h times b is happening on this side, we can divide both sides by b to get h alone. Divide by b, that would cross, I'm going to use blue, cross that out, so h is now alone. And on this side it just says a divided by b, which we would write like this, a over b equals h. Now that we have h all alone, we would say, okay, this is our answer. So this was one of our more simple literal equations. You're just solving for h, trying to get h all alone by manipulating both sides. Example 2 is very, very similar. It's r times t equals d. Now this is a formula for distance. Distance equals rate times time. So however fast you are going, your speed, times the time, that'll tell you the distance you go. So if you're going 60 miles an hour for 3 hours, you would do 60 times 3 to get 180 miles traveled. Okay, so this is the formula, distance formula. We want to be able to solve for the rate. So if I told you how far you went, and I told you how long it took you to get there, you should be able to tell me the speed. Okay, it's very similar to this side. If it's rate times time, we can just divide both sides by time, or divide by t. So again, that would cross the t out here. So now it's d divided by t equals r, or d over t equals r. Okay, and this is how we solve literal equations. Now these ones were more simple. They were just one step. We're going to jump into more difficult ones that might have more than one step. Now one thing to always keep in mind is your order of operations. Okay, remember parentheses, exponents, multiply and divide, and then add and subtract. Okay, PEMDAS, GEMDAS, whatever you want to call it, you always have to remember your order of operations as to what is happening to your variable first. So in this case, c equals 2r, or 2 pi r. Okay, this is circumference equals 2 times pi times the radius. This is how to find the circumference of a circle. Okay, we want to figure out how can you find the radius if somebody told you the circumference. Okay, so this is just how to rearrange this formula so that you would find the radius instead of finding the circumference. Well, again, notice what is happening to r. r is being multiplied by 2 and pi at the same time. Now that's all technically one step because on our order of operations, multiplication and division all happen at the same time. So these two multiplying problems, multiplying by 2 and multiplying by pi, happen together. So we can take care of them both at the same time by saying divide by 2 pi, divide by 2 pi. When we divide by 2 pi, takes out the, I'm going to use blue, takes out the 2 pi. So r is alone on this side. And now it's c over, or divided by, 2 pi. So if you were given the circumference and you wanted to find the radius, you would just divide circumference by 2 pi, and you would know the radius of the circle. Okay, in example 4, we're kind of moving away from formulas, and now we just have kind of more our typical or standard equations. This one's saying 4m minus 3n equals 8. And we're trying to get m alone. That would be this one right here. So one way that I want you to think about this is to think about what is actually happening to our variable m. So in this case, thinking of your order of operations, what's happening to m? Now normally, we wouldn't necessarily think that we're doing m, then take away 3, then multiply by n, then multiply by 4. That just doesn't make sense with our order of operations. The first thing that's happening to m, because it has this 4 right next to it, is that it's being multiplied by 4. We're saying m times 4, that would give us 4m. Then what happens after that? The next thing is we are subtracting 3n from it. So start with m, multiply by 4, that's how we got 4m, and then take away 3n, that's right there. That completes this whole expression. Remember, expression is just the one side of the equation. That completes all of this. And then we would say it's equal to 8. That equals 8 is what makes it an equation then. So to help you think about what you should do to both sides of the equation, we just work backwards. Instead of going from m all the way to 8, we want to do 8 going back to m, which means we work exactly opposite from what we did. So as we travel from 8 back to m, we just do the opposite of what we did. So instead of minus 3n, we would be adding 3n to both sides. When you add 3n to both sides, it cancels this out here. And now the only thing left on this side of the equation is 4m. So now it says 4n equals 3n plus 8. And again, remember, you can also think of this as 8 plus 3n. They can flip-flop, that's okay, as long as they both stay positive. This is a positive 8, this is a positive 3n. We normally write it with the variables out front, though, so that's why it's written as 3n plus 8. Okay? The next thing we do as we're moving back towards m is the opposite of this step. So instead of times 4, we would be dividing by 4 on both sides. Okay? That would leave m all alone, because we are, oops, I need my marker, crossing that out, taking out the times 4 and the divide by 4. So now it's this entire side is being divided by 4. Now again, remember, your order of operations is what counts here. When we have this whole piece, we're kind of thinking of it in parentheses. We're doing all of this first before dividing by 4. So there's two ways you can look at this. You can either do the divide by 4 to each piece individually. Remember from our review, this is like distributing. This is our distributive property. You can either distribute the 4 to each of these, or you can write it still kind of on the outside or separated from these altogether. So if you did it all together, it would look like this, 3n plus 8. Do all of that first and then divide by 4. When there's the bar like that, there's kind of like a hidden parentheses here. It's saying do all of this first, then divide by 4. If you did want to do it the distributive way, so you're putting the 4 with each of these pieces individually, it would look like this. Okay, the 4 is being divided from the 3, and then that whole thing is being multiplied by n. It was 3 times n before, but then we divided it by 4. So 3 times n divided by 4, we call it 3/4 m. Plus 8 divided by 4, well, we know that right away is 2. So we would call it 2 instead of 8 divided by 4. Either of these is an acceptable answer for m. You can call it either one as long as you do your steps correctly. Add 3n to both sides, divide by 4 on both sides. Going on to example 5. As we work through this one, again, we're going to think just like our last one. Let's keep our order of operations in mind and think about what is happening to the variable. So in this situation, we're looking for k. What is happening to this k first? Is it being divided by 5 first, or subtracting the 2. Now remember, when there's this bar, there's kind of a hidden parentheses here. So it's saying all of this is happening first, then dividing by 5. So technically, what's happening is k is being, we're taking k, we're subtracting 2, then we're dividing 5, and in the end, that's going to equal this 11j. So as we work our way backwards from 11j to k, getting k all alone, we just do the opposite of each of those steps. Instead of divide by 5, we multiply by 5 on each side. Multiplying by 5 gets rid of this here, and then it leaves on the right side, instead of 11j, it's now 55j. So k minus 2 equals 55j. I think I should be able to shrink that just a little bit here. Again, as we work our way back over, instead of minus 2, we're adding 2 to both sides. Just get rid of that. This adding 2, notice it doesn't make this a 57j. 57j is all one term. When you add or subtract from both sides, unless they can be combined. If we were adding 2j, then we could combine it. But this is a 55j, this is just 2 alone, so it creates a whole new term. Adding and subtracting will usually create new terms unless they're the same term. So unless this was a 2j, then it would make it a 57j, but because it's just 2 as a constant, it creates a new term. And we now have our answer. K alone is this 55j plus 2. Okay, let's go on to example 6. We're trying to get t alone. So here we have t on the outside of this parentheses r plus 4. Now remember, this means t is being multiplied by this whole thing. We can think of this as almost one big number. Now at first we might be tempted to say, all right, we better start distributing. But if you think about it, r plus 4 needs to happen first before we can multiply t. But t is what we want alone. So we can keep r plus 4 as one number and just divide that whole thing. We'll divide, and we want to kind of keep it in parentheses. We're dividing this whole thing. We're not dividing by r. We're not dividing by 4. We're dividing by r plus 4. When you do that, that full thing, the r plus 4, is what gets taken away. Now, since it's 28 divided by this whole thing, we would need to include that bar underneath it. So it's 28 over this whole answer, r plus 4. And if you don't like keeping those parentheses on there, you don't have to, as long as that bar separates them. So you could just simply say 28 over r plus 4. If you want the parentheses, you can put those in there as well. But in the end, this will be your answer. T alone is the same as or equivalent to 28 over r plus 4. Last two examples. For example 7, since we're trying to get y alone, right here, and it has this minus in front of it, I want you to think about smatoing it. Remember, subtraction means add the opposite. So instead of thinking of it as x minus 2/3 y, thinking of it as x plus negative 2/3 y. Now that it's an x plus something, this helps us see why we can flip them around and rearrange it. Since these two are our numbers, positive x and negative 2/3 y, we can flip those around and rearrange our equation to look like this. Negative 2/3 y plus x. We only have two terms here, our positive x and our negative 2/3 y. These are two separate terms. So we can rearrange them. Negative 2/3 y is over here, positive x is over here. Now it's a little easier to see what is happening to y. First, y is being multiplied by negative 2/3. Then we're adding x. And in the end, that equals 12. So as we work backwards, we would subtract x first. And that's going to look like this. We will have negative 2/3 y equals negative x, because we subtracted it, plus 12. Now what are we doing to both sides? We're dividing by the same thing we were multiplying by. We're dividing by the negative 2/3 on both sides. When you do that, this cancels out, and y is finally alone. And now, and something to think about is this technically means the same as multiplying by negative 3/2. Dividing by a fraction, over here it's the same as multiplying by the reciprocal. So that might make it a little bit easier to think about. Think multiply by 3 or negative 3/2. So now we would say y equals positive 3/2 x, because negative and negative cancel out. So 3/2 x, this positive or plus becomes a minus because we're multiplying by a negative. 12 times 3/2 becomes 18. So y equals 3/2 x minus 18. The big concept here is to always think whatever variable you're trying to get alone, think about what's happening to that variable and work backwards. On our last example, example 8, we are solving for q. Okay, that's right here. Because these parentheses are here, we think everything inside the parentheses are happening first, then everything outside the parentheses. So the first thing happening to q is that we're subtracting 8. So to undo that, we would have to add 8, but we would do that at the end. The next thing is that we are multiplying by a. So again, because, actually I'm going to draw this one out. We have q. We are minusing 8. Then we are multiplying by a. I'm going to write this uppercase. And that finally equals 23. So, to get back to q, we do everything in reverse. Divide by a, then add 8. Okay? This divide by a, we'll do on both sides, gets rid of this a over here. No longer have that. So it's just q minus 8. 23 divided by a, well, we don't know how big a is, so it just creates this term, 23 over a. Now remember, this is all technically just one term because it's not separated by a plus or a minus. So the next thing we have to do is add 8 to both sides. We get q alone equals 23 over a, which is one separate term. Since we added 8, that's a whole new term, simply because it has nothing to do with a. If there was a certain amount of a, then it would change this term. But because this is a constant, and this is a variable term, they're two separate things, so it has to become q equals 23 divided by a, and then add the 8 as separate terms. And that'll cover it. We'll be done for 1.3.